So I know a lot of you out there have been wondering about all these large language models that are popping up everywhere. Like, how well do they actually perform when it comes to generating code, especially in specific types of software development?
Hmm.
And well, we decided to take a deep dive into a new research paper to get you some
Oh,
answers.
that's cool.
Yeah. It's called How Well Do LLMs Generate Code for Different Application Domains? Benchmark and Evaluation
Okay.
by Duwu Zhang and their team from Sun Yat-sen University.
Interesting.
And they didn't just theorize about it. They actually put 11 popular LLMs to the test,
Mm-hmm.
even comparing those big names like GPT-4 to some open source models that you might not even be familiar with.
That sounds interesting.
Yeah, and get this, the results really kind of challenge the idea that bigger models are always better.
Mm-hmm.
Yeah, so this research really digs into the limitations of the typical benchmarks that are used to assess code generation, like human eval. I mean, those benchmarks are great for a general sense of how well an LLM can code, but they don't really tell the whole story when it comes to those real-world projects.
So that's where MultiCodeBench comes in, right?
Yeah, exactly.
Yeah. It's a new benchmark designed to evaluate LLM performance across 12 different software domains using 15 different programming languages.
Wow.
Yeah. So think blockchain, web development with all of its the subdomains like React,
Right.
mobile development, data analysis, like all of it.
Yeah.
To make sure this benchmark was really representative, the researchers chose 2,400 real-world coding problems from high-quality GitHub repositories, carefully rewriting them to avoid something called data leakage.
Oh, data leakage. What's that?
So imagine an LLM acing a test because it's already seen the answers.
Oh,
That's data leakage.
I get it.
So this careful approach makes the findings much more reliable.
So all of that sounds super thorough, but wouldn't actually running 2,400 coding tasks to test these LLMs be incredibly time-consuming?
Well, you're right. That's why they used a specialized evaluation metric called CodeBLEU, and it actually goes beyond just seeing if the code runs. It analyzes the structure and the logic of the generated code to determine how well it matches the intended solution.
So it's like comparing blueprints rather than just checking if the house stands up, basically.
Yeah.
Gotcha. So they have this super robust benchmark and a way to measure results accurately. So what did they find when they put those 11 LLMs through their paces?
Well, first surprise was LLMs as a whole didn't do very well on MultiCodeBench, which really highlights this gap between how LLMs perform on theoretical benchmarks and how they handle real-world coding.
Yeah, that makes sense.
And here's the real shocker. DeepSeek Coder 33B, which is an open-source model, consistently outperformed even GPT-4 across various domains.
Wow. So it really challenges that assumption that bigger models always perform better. So it's not just about size. Were there other interesting findings, in how these models stacked up against each other?
Well, model size didn't consistently predict performance. In fact, the 15.5 billion parameter StarCoder often fell short compared to the 7 billion parameter CodeLlama. And while LLMs generally excelled in domains like blockchain and mobile development, they struggled with web and enterprise app development.
Wow. So it sounds like choosing the right LLM for a specific coding task is a lot more nuanced than just picking, the biggest name out there.
It really is.
Were there any particularly striking examples of those domain-specific performance differences?
Well, within data analysis, for example, LLMs were surprisingly adept at using the pandas library,
Yeah.
but stumbled when tasked with using SATS models.
Really?
Yeah, and this is exactly the kind of insight that can help developers choose the right tool for the job. It even gets more interesting, though. 2 LLMs with nearly identical scores on the human eval benchmark, DeepSeek Coder 6.7b and StarCoder 215b, showed very different strengths and weaknesses across the 12 domains.
So even if 2 models seem similar on the surface, their performance can vary drastically depending on the specific coding task at hand. So what was it about these real-world coding scenarios that tripped up even the most advanced LLMs?
Well, the researchers took a deep dive into the reasons behind GPT 3.5's struggles.
Okay.
And I think this gives a really valuable window into the broader challenges faced by a lot of LLMs.
Yeah.
They identified 5 key factors that contributed to these coding failures.
So let's break those down. What was the first hurdle for these models?
Well, first, they often failed to fully understand the requirements outlined in those coding instructions. Those are known as docstrings.
Right.
Second, and this might be the most important one, they lacked crucial repository context.
So the ability to understand how a specific piece of code fits within the larger project.
Yeah.
So it makes sense that without that broader understanding, an LLM might struggle to generate code that actually works within the ecosystem of a complex project.
So what were the other factors? Well, third, even when an LLM had theoretically, seen a particular library during its training, it often lacked the specific knowledge needed to use that library effectively in a given context.
Oh,
So this issue with third-party libraries was a major stumbling block.
interesting.
Fourth, LLMs often faltered due to a lack of understanding of domain-specific algorithms, processes, or methods.
Okay.
It's one thing to know how to write code,
Yeah.
but it's quite another to grasp how something like blockchain transactions actually work.
Makes sense.
Finally, while less frequent, issues with specific programming language features also contributed to some of the failures.
So out of those 5 culprits, which ones seem to be the biggest roadblocks for LLMs like GPT 3.5?
Well, the lack of repository context was really the primary culprit. Imagine trying to solve a puzzle with only a few pieces. That's essentially what these LLMs were facing.
Right.
Closely related was the issue of those third-party libraries.
Uh-huh.
It's like having a toolbox full of tools, but not knowing how to use them properly for a specific task.
Yeah, I get it. So it wasn't just about, finding the problems. They actually looked at how to make things better, huh?
Yeah, the researchers really wanted to see if providing more context to those LLMs would actually improve their performance.
Uh-huh.
So they experimented with adding different types of information to the prompts, like import statements, code from the same file, details about the project's dependencies, even information about the APIs that are being used,
Okay.
both like generally and specific to that project.
So did adding that extra context actually make a difference? Did they get better?
Yeah, providing more context really did lead to improvements in performance.
Okay.
Especially info about the project's dependencies and the APIs that were needed.
Yeah.
And you know what? It suggests that these LLMs aren't just memorizing code snippets. They're starting to understand the relationships, the logic, behind how code actually functions within a larger system.
So that's pretty promising, right?
Yeah.
It seems like if we can figure out how to, give LLMs the right kind of contextual information,
Right.
they could really become even more powerful tools for developers.
Yeah.
Did they see any specific trends when they were messing around with those different types of contexts?
Well, adding that repository context and the API information, that generally helped.
Uh-huh.
Especially when they gave the LLMs both the API details that were needed and the information about the project's dependencies.
Right.
But, sometimes those Code-Llama models struggled when they were given a lot of, local file context.
Really?
Yeah, which indicates that too much information can actually be a bad thing.
So it's got to be like a balance.
Yeah, too little, and the LLM is lost. Too much, and it gets bogged down.
That's interesting. So what would you say is the main takeaway here for developers who want to use LLMs for coding well?
Be specific. Give them a lot of context.
Okay.
You got to outline those project dependencies,
Right.
The APIs that you're using, how the code actually fits into that big project.
Right.
The more information that the LLM gets,
Yeah.
the better it's going to be able to understand the task and generate the code you want.
It's almost like you're treating the LLM like a junior developer, right?
Yeah.
Giving them all the information they need to get up to speed.
Exactly.
Did they have any overall conclusions about how context affects LLM performance when it comes to generating code?
They really highlighted that providing that appropriate context is absolutely essential for unlocking the full potential of these tools.
Yeah, that makes sense.
And, this study provides some really valuable insight into how LLMs approach those complex coding tasks.
Right.
And how we can actually help them, succeed.
So it's not just about picking the LLM with the biggest name or the most parameters.
Right.
It's more about understanding their limitations
Yeah.
and how to guide them with the right context.
Yeah.
That'll be key as they become more and more integrated into how we develop software. Yeah, this has been really fascinating looking at how these LLMs handle, real world coding.
It has.
And it seems like there's still so much more to discover.
Well, yeah, absolutely. It's such an early stage.
Yeah. About how to really use these powerful models,
Yeah.
In the best way.
Mm-hmm. This research was all about code generation.
Right.
But I think this whole idea of providing the right context,
Yeah.
that probably applies to anything an LLM is doing, really.
It really makes you wonder,
Yeah,
what are we missing when we're, talking to these things every day?
exactly.
Well, thanks for joining us on this deep dive into LLMs and code generation.
It was fun. It was a pleasure to, explore all this stuff with you.
Yeah, absolutely. And until next time, happy coding, everyone.